about this? I don't understand. Do you understand what I was talking about?
Wasn't even pretending that time.
That's surprising. Because like you never understand what I'm saying. You're like,
It's not actually your job to make me feel bad about myself.
no, I'm just like surprised that you don't because you never talk.
Just be quiet.
No offense.
But I can't. Okay. What do you
That's
have?
really funny. Funny.
You said we're back. I was like, what?
I'm color coding and I don't have
then I
red.
did angle 7 and angle 3, which makes some corresponding angles.
Wait, is this I just know how to diagnose these. Give me a clue. Oh, I need to. That's not bad. I mean, it's like my dad going So don't take that super seriously. How are shells?
They got the painted and then
What did I do?
I got this angle 7 and angle 6 and semicolon angle 3 and angle 2 are supplementary angles. That's
It's a little bit different, but not bad.
Oh, okay. I was like,
Oh my gosh, I flip out every time.
this and 6
what the heck was that?
Would you like to go over that?
Yeah,
So then you subtract.
Sorry, I didn't mean to like.
Brother, tell you I saw him.
just like Pitch can explain. Oh, thank you.
I've had that happen.
Yeah,
Except mine didn't have anything in it. It was just
Go, guys. How was your
I feel like I have them, like I understand how to do them, but I'm probably wrong on all the steps. I hope not, but I might be.
yeah, like you don't have to figure out because you're not learning anything or not learning anything.
They just went off together and I'm sorry.
No, it's alright.
I was freaked in. We were going
Oh, because it freaked out that
Well, I
They actually did make sense though. Good.
That's it. That's kind of. I'm still surprised you understand what I'm saying about.
Did you?
You're over 80.
Well, no, but you started doing a visual like representation, so it makes sense now.
94.
Yeah.
77.5.
Yeah. I should start.
101.
No.
What'd you get?
Why is that?
And then 102.
Turn around.
Yeah.
Okay. It is dice. I just saw it. I was like, but it just went once. So now I have 1.
Did you end up
Going on stage and hitting hockey.
Yeah, and get some old bands.
No, we made a
I got
given,
given, then Pastel 11, then Theorem
I'm not kidding.
215.
Like, what were the gift cards for? What were the gift cards for?
Probably where I went down.
I'm sorry, go ahead, I'm sorry.
I said,
Sorry. Ophelia, I just did that. I just did it. Okay, thank you. I really don't.
Restaurant. I don't know what I did. I tried to give it.
It was like
given
Definitions corresponding equals.
Okay.
I was just asking
Yeah.
that.
Hopefully, I think she'll just probably do all of them. That's given. How much are they? What they?
No, there were 25. Yeah.
Yeah.
So, we call down the number and find ourselves.
Can I have your attention, please?
So
I know
don't.
some of you are still discussing, some of you are finished. So let's see what questions you have on the assignment. Were there any questions on 1 through 12? Aaron? Aaron?
Actually, it's come through 11 because we.
Okay,
said-
what, were there any questions on that section? Yes?
Yes, 11, please.
11? The measure of angle 12 plus the measure of angle 15 equals 156. What's the measure of angle 6? Okay, so if 12 plus 15 is 156, what could we say about those two angles? Anna?
Well, they're vertical, so they're congruent.
Right, so they're congruent, so how would you figure out what each of those would be? Anna?
You divide 156 by 2.
Right, so if you divide 156 by 2, which gives you what? What? 78. That is the measure of angle 12 and also the measure of angle 15. What is the relationship of angle 6 to those angles? Okay. How do you know that? Oh, I still have to look at the picture. They are supplementary if you go in a roundabout way with all of the parallel lines and transversals. So here's 12 and 15. It doesn't really matter which one you're looking at. If I look at 15, then I know 15 is corresponding to 7. And 7 is corresponding to 5. And 6 is over here. So 15 and 5 are going to be congruent. And 5 and 6 will add to be 180. So you would do 180 minus 78 to get angle 6, which would be what? Does that make sense? Other questions on that section? Sarah?
Number 3.
Number 3, the measure of angle 8 equals 110. What's the measure of angle 1? Okay, so 8, here's 8, and here's 1. Alright, so what's the relationship of the measure of angle 8 and the measure of angle 1? Hannah?
Well, 1 and 6 are vertical angles, and angle 6 and angle 8 are corresponding.
Okay, right. 1 and 6 are vertical angles, so that must be that they're congruent. And 6 and 8 are corresponding, so they're congruent. So therefore, 1 and 8 are congruent. So for number 3, the measure of angle 1 will be the same as the measure of angle 8, which is 110. Does that make sense?
Mm-hmm.
Yes? Okay, other questions on that part? Aaron?
17.
Was there anything else on 1 through 11? Alan?
9.
9, 5 plus 7 equals 158. What's the measure of angle 12? Okay, what do we know about 5 and 7? Sarah?
They're corresponding.
They're corresponding, and therefore they are
Congruent.
congruent. Good. So 5 and 7 are congruent. So just like we did for number 11, we will divide 158 by 2 to figure out what 5 and 7 are, which would be what?
9.
So that goes for 5 and 7. And they're asking you for 12. Okay, so we have 5, 7, and 12. And what do we know? 5 and 7 are
Corresponding.
corresponding, we said already. And what about 7 and 12?
Alternate interior angles.
Yes. And what do we know about alternate interior angles?
They're congruent.
They're they're congruent, so the measure of angle 12 then must be 79 also. Okay? Anything else on 1 through 12, that section? No? Okay, then the proofs. What questions do you have about those? Aaron? 17, you're proving that angle 1 is congruent to angle 3. So who can tell us what steps they took for that? Okay.
First I did that line AB is parallel to line AC and line BC is parallel to line EF given.
Okay.
And then, I said angle 1 is corresponding to angle 2, definitions for corresponding angles. And then 2 is corresponding to 3, and same definition. And then for 4 I did 1 is congruent to 3 and substitution principle.
Okay, we might want to add in just a few things here. We might want to add then, after step 2, that angle 1 is congruent to angle 2 because of postulate 11, right? I like your thought process. We just need to add a few things. And then you said angle 2 is corresponding to angle 3, so that would be still the definition of corresponding angles. And then again, you want to say then angle 2 is congruent to angle 3 by postulate 11. And then we can say that angle 1 is congruent to angle 3. You could say substitution, or what else could you say? Did anyone say something else? Wolfie?
Theorem 215,
Right. Theorem 215 transitive, or instead of writing it that way, you could just say, congruence of angles is transitive. Is that what you said? I'm trying to think of how I want to say. Yeah, you could say congruence of angles is transitive, which is what theorem 215 says. Morgan?
Could you leave out steps 2, 3, and 5? And wait, because I said number 1 is both givens, and then I said angle 1 and angle 3 are corresponding angles, to the definition of corresponding angles, and then for number 3 I said angle 1 is congruent to angle 3 in postulate.
Well, angle 1 and angle 3 are not corresponding angles.
Okay.
In a roundabout way, they are going to be congruent because 1 is corresponding to 2 and 2 is corresponding to 3. But angle 1 and angle 3 are actually not corresponding because they aren't cut by the same transversal.
But if line FE goes on forever, why wouldn't
those two angles still wouldn't be cut by the same transversal, because they're not the same set of parallel they are the same set of parallel lines. They wouldn't have the same line that would be cutting them. Like FE is the transversal for angle 3 and CB is the transversal for angle 1. It has to be the same line that's cutting them in order to say that they're corresponding angles.
Oh.
Do you know what I'm saying?
Yeah,
Yeah, are you sure?
kind of.
Madeline?
Could you combine 2 and 4 and 3 and 5?
Yes.
Okay.
Yes, you can. They have the same reasons, so anytime they have the same reasons, you can combine them.
Okay.
Other questions about that? Okay, what else? Maddie?
For number 15, I wasn't sure if you needed to put that, the line that like cuts through all the parallel lines is, what was it, transversal? Yeah. If you needed to state that or not, if it doesn't like label that line.
That's a good question. No, you don't. You can assume that that's a transversal because it does intersect all of them. So you can use any of the theorems that talk about the parallel lines and the transversal for that.
Can you do number 15?
Number 15 should be pretty quick, right? You would just say the given. You don't have to say the plane figure, but you could just say, you only need J and L, really. Oh, but it says, alright. It says J is parallel to K, and K is parallel to L. So, and so then from that, what can we say? Morgan?
J is parallel to L in transitive property.
I'm thinking about the reason for that as well, because we don't know that parallel is transitive. I mean, it is, but we don't have anything that really says that. What did you guys, did anybody use something different for that? Patty?
I just want substitution.
Substitution. I have to think about that. What about the definition of parallel lines? What does that say? Line. That's what I'm leaning towards, honestly, the definition of parallel lines. But I see where you're going with the transitive and the substitution, and I would probably not count that wrong on a test. But we just don't know that parallelness is transitive. Madeline?
How, like, wouldn't she know? Because, like, if they're, like, parallel to each other, then, like, how could it, like, change the, like...
If one is parallel to another and then another is parallel to another, then we would know that the original wouldn't have any points in common with the other one. Based on the definition of parallel lines, I would say, which was not clear on the place where I was just looking. Which says, when the intersection, no. Lines that lie in the same plane and have no point in common. So, yeah, I still have to think about that though. But we can definitely say that J is parallel to L. I would accept all of those reasons, transitive and substitution. And then, since J is parallel to L, what can we say then? Sarah?
Angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3.
I would say one other thing about them first. We really don't even need angle 2. I would just go and say angle 1 is what to angle 3 before we say it's congruent. Matt?
Corresponding.
Yeah, let's say angle 1 is corresponding to angle 3 because of the definition of corresponding angles, and then we can say that angle 1 is congruent to angle 3 because of what? Morgan?
Postulate 11.
Postulate 11.
And I have a question.
Okay.
I got that, but how is 1 corresponding to 3 in this one, but not 17?
Because the line that, the transversal, the line that cuts through the parallel lines is the same line for angle 1 and angle 3. Let me try to draw a picture. So here, it doesn't, we don't even need K, we just need J and L and this transversal, which like Millie said is not named for you. So 1 and 3 are formed by the same transversal. So here's the transversal. There's one line that's forming both of these angles with the parallel lines, right? Whereas in, what was it, 17?
Yeah.
In 17, even if, like you said, if we extend this FE here, these are 2 separate transversals. Here's one transversal. We could consider all of them transversals actually, because they're all parallel. And here's another one. So whichever angle, what were we talking about? 3 and 1. 3 is formed by the green transversal, and 1 is formed by the orange transversal. They're separate lines.
But if they're parallel, wouldn't that make them have like the same measure?
They do have the same measure, absolutely, yes. But you can't just jump and say that they're not corresponding. They do have the same measure because 1 will be corresponding to 2 and 2 would be corresponding to 3. They do have the same measure, but they're not corresponding angles by definition. Because they're not formed by the same transversal.
Is there a name for those?
No. That's why we had to prove it that way and say that, yeah.
Okay. Thank you.
Uh-huh. Alright, what else? Any more questions? Mylan?
21.
21? Sorry about that, my phone is really loud, even if it's really silent. Given that L is parallel to N, prove that the measure of angle 3 plus the measure of angle 6 equals 180. Alright, so what do we start with? L is parallel to N, which was given. So then what can we say? Okay.
3 is an 3 and 5 are alternate interior angles.
And just looking at this, I think there's a lot of different ways you could probably go with it. There's a lot of different relationships that we can use. So if you don't have it the way that we're doing it, doesn't necessarily mean that it's wrong. But that is one good way to start. Angle 3 and angle 5 are alternate interior angles by the definition, right?
Mm-hmm.
Okay,
And then,
go ahead.
okay, I had, that 5 and 6 and then 3 and 6 are supplementary angles. Like, I had them as 2 separate. Like, first I put 5 and 6 are supplementary, and then 3 and 6 are.
Maybe we should first say that 3 and 5 are congruent. So, angle 3 is congruent to angle 5 based on what? Theorem 3-1. And then we can say that angle 5 and angle 6 are supplementary angles. What's the reason for that?
I put definition of supplementary. It's probably.
I'm thinking it's theorem 2-1 if I remember correctly. Is that what you put, Maddie? Which says that if two angles are adjacent and their exterior sides form a line, then they're supplementary. And so then we could use substitution and say then that angle 3 and angle 6. Is that what you said, substitution for that?
Yeah.
Are supplementary angles? And then you do have to say that the measure of angle 3 plus the measure of angle 6 equals 180, and that would be because of what?
I put substitution, but I think it's wrong.
It is, but thank you
Okay.
for volunteering. Anything else? Alan?
Did you do the definition of supplementary?
That would be the
angles?
definition of supplementary angle, yes. Okay. So, I was kind of interested actually to see that your book only gives you those two, one's a postulate and one's a theorem, but only gives you those two relationships of congruency. Because as some of you have already found out, there's a lot of other things that we can prove to be congruent, and in my experience with geometry, we talk about all of the ways that they're congruent and all of the ways that certain things are supplementary. But your book is actually having you prove them, which makes me wonder about how it's going to work in future sections if you have to say that. I wonder if you're gonna have to like go through the steps of proving it every time. I guess you would, because there's no theorems that say that. But you can see that they've only given you two theorems and postulates. They've given you corresponding angles. Corresponding angles are congruent. And they've given you that alternate interior angles are congruent. What else have you been able to prove about the relationship of two parallel lines and a transversal? Sarah?
Postulate 11.
Postulate 11, which is the one that says that the corresponding angles are congruent. That is postulate 11 that says that. And this is theorem 3-1. But there's a lot of other things that are going to always be true for two parallel lines cut by a transversal. Mac?
Postulate 213.
I'm not looking for postulates and theorems. I'm looking for what can you say? Like, okay, so we know alternate interior angles are congruent. What about alternate exterior angles? What about consecutive interior angles, consecutive exterior angles? Madeline?
Could you always say like there's gonna be like some sort of like vertical angles? Cause like
Right, so because of the vertical angles, what could you say? If you know that the alternate interior angles, say 3 and 6, are congruent, what could you say about the alternate exterior angles 7 and 2?
that 7 is congruent with 3.
7 is congruent to 3 because those two are corresponding, but what about 7 and 2? 7 and 2 will always be congruent, so will 1 and 8. So you also know that alternate exterior angles are congruent, but we don't have any theorems that say that. But we know because of vertical angles and because of alternate interior angles that they are.